All right, so today we're going to do lessons 1.2 and 1.3. We're going to start off with lesson 1.2, which is exponents and powers. All right? The first problem that I have here is really not even a problem. It's just a model that I want to talk to you about. And it is what we're going to be looking at when we do exponents and powers. Now, this whole problem right here, this whole problem, okay, is called a power. Just like when I look at, let's say, a football team, okay, I call that a football team. There's a bunch of different people on it. There's different positions. There's running back, wide receiver, quarterback, whatever it is, okay? But we call the whole thing a football team. That is exactly like this right here. I've got different pieces, but I call the whole thing a power. So if I were to ever say evaluate the power, that just means solve the problem, okay? These specific pieces, though, that go in this power, the first one is the base. The base is always the number that's at the bottom. If you think about cheerleading, the base is the girl on the bottom, holding the whole thing together, the stunt together, okay? So that's what our number is. The exponent is the smaller number at the top right-hand corner, okay? I will never have an exponent that looks like this. It'll never be written on the left-hand side, okay? That's just wrong. It goes over here on the right-hand side, okay? So this is my base. This would be my exponent. The whole thing is called a power, okay? So now you're familiar with the terminology. And what they want us to do on example 1 is they want us to label the expression. They do not want us to solve it, okay? That way, tomorrow when I'm calling out the homework answers, I know that as I'm reading it, you know what each exponent says. So if you were to look at this right here and read it out loud, what would you say? Who knows how you would read that first problem? Michaela?
10 to the first power.
Perfect. That's what I want you to write. 10 to the first power. All right, it's always read the base number first. So this is my base, 10. So I say 10 to the whatever my exponent is comes next. So this one, it's first power. Okay. Now, the next two problems is what I really want to focus on, because these are the only two powers that actually have nicknames, okay? We could read that 4 to the second power or 5 to the third power, but they are more familiarly called 4 squared and 5 cubed, okay? The easiest mistake that people make is they get squared and cubed mixed up. They think squared is 3 and cubed is 2, but it is not. So if I wanted to write this, or if I read this, I would say 4 squared. So just remember, squared means it has an exponent of 2, and cubed means it has an exponent of 3. So I would write this 5 cubed. And again, you always start with the base first. So I'd say 5 and then write my power. All right, lastly, this last one. So every other power other than 2 or 3 are read just like that first one. I'd say the base first and then to the whatever power. So Trevor, how would I say this last one?
7 to the 9th power.
Perfect. 7 to the 9th power. Okay. Okay, so the next example, what they want us to do is they want us to evaluate the power. Basically, they want me to plug in this variable, x, when it equals 3, and solve the power. Okay, so I'm going to do that. 3 is my what in this problem? Base, very good. And then 4 is my exponent. Perfect. Okay. Does this mean 3 times 4, which equals 12? No, it does not. This exponent right here tells me how many times my base is multiplied by itself. So this tells me I've got 3 and it's multiplied by itself 4 times. So 3 times 3 times 3 times 3. Now I want you to write this down for your notes' sake. When you do your homework, you don't have to write this step down. You can plug it in your calculator and find the answer. But I do want you to write it down on the notes. Okay? Now I would plug this in my calculator. 3 to the 4th power. And I would press equals or enter, and I'm going to get 81. And that would be my answer there. Okay, so that is all for lesson 1.2, doing powers. Now we're moving right along to lesson 1.3, which is order of operations. Order of operations, okay? And how many of you have heard of order of operations before? A more familiar way to hear it may be please excuse my dear Aunt Sally, or PEMDAS, okay? Either one of those ways is order of operations. What they stand for is parentheses, exponents, multiplication, division, addition, and subtraction. Okay, so let's talk about each of these steps. The first one, parentheses. When I see a math problem, okay, in general, you're going to have a lot of different pieces to do typically. And if you don't have a specific order that you do those pieces in, you could get different answers. Like if I were to do 5 times 2 plus 3, I could get 2 different answers with this problem. If I do it the correct way, order of operations, I would do 5 times 2, which is 10, plus 3, which is 13. However, if I did it incorrectly, I could also get 5 times 2 plus 3, which is 5, which equals 25. Oops, that was supposed to be 13 there, okay? Which is incorrect. So order of operations is very important. So the first step in order of operations is parentheses. Now this first step is where most mistakes are made. It's a very careless mistake, something really easy to fix, but people look at problems like this. And they go, okay, parentheses, that's going to be 10 parentheses. No, okay? Parentheses means that there is something inside of the parentheses that has to be done. In order for it to fall under the parentheses category, there has to be more than one number inside of the parentheses. This does not count. What are these parentheses telling me to do? What operation, Michaela? Multiplication. Look right here. Here's multiplication. It doesn't come till third. So I cannot do that first. If I do, I will get a wrong answer. Okay? So parentheses means there's got to be more than one number inside of the parentheses, and there's got to be something for me to do in there. So on this one, perfect. 7 times 2. So I'm just going to rewrite everything else because I'm not working it yet. 7 times 2 is 14. Once you've done what's inside of the parentheses, you can drop the parentheses. I don't need to keep the parentheses around 14. Okay? My next step is exponents. So I look around. Do I have any exponents? Yes, I do. Jennifer, what would I do first?
Multiply, do the 2 with the exponent.
Exactly, 2 to the 3rd power. So, 2 to the 3rd power is 8. And I solve that. Now I move on to multiplication. Now is the time that I would look in those parentheses. I would take care of them because they represent multiplication. So I do 5 times 8, which is 40. Then I don't have any division, so I can skip it. Addition I have, so I do 40 plus 14, which is 54. And I don't have any subtraction. Obviously, this is my final answer. Okay? Now, there's one other rule that I want you to write down that I did not write on this page. It is called the left to right rule. Okay? Write this down. Left to right rule. And what the left to right rule says is that multiplication and division are equal to each other, and addition and subtraction are equal to each other. What that means is basically when you write something, I have to put the M and then the D, or the multiplication and the division, because I can't write them together. I can't combine the M and the D. However, when they are both in a problem, they are equal. So I wouldn't always do multiplication first. I follow the left to right rule. If you think about it, how do we read? We go from the left to the right. That's exactly how we would solve a problem. So if I had a problem like 27 divided by 3 times 2, what I would do is I would not go, oh, well, I need to do 3 times 2 first because multiplication comes first. No, multiplication and division are equal to one another, so I just go from left to right. So I would do 27 divided by 3 first, which is 9. Then I would multiply it times 2, which is 18. If you did multiplication then division, you would get a different answer, okay? Now, same exact thing goes for addition and subtraction. They are equal to one another, okay? So, if I saw them both in a problem, if I saw 12 minus 6 plus 6, okay? What I would do here is I would have to solve this from left to right. 12 minus 6 is 6, plus 6 is 12, okay? If I did it the other way, okay, I would do 6 plus 6, which is 12. 12 minus 12, which is 0. Which technically, this 6 right here is a negative, and that's why it throws people off, which we will deal with that on down in the year. So you don't have to worry about it now, okay? But just remember, multiplication and division are equal. Then, right underneath them, addition and subtraction are equal, and I follow the left to right rule. All right, so let's do this first example here then. What they want me to do is they want me to plug in they want me to plug in 3 for x, and they want me to use order of operations to solve these problems. So I'm going to have 4 times 3 squared minus 8. 4 times 3 squared minus 8. I look. Do I have any parentheses? No, because these parentheses do not mean parentheses in order of operations. What do these parentheses symbolize? Multiplication. Very good. So I skip it. No parentheses. Exponents. Do I have an exponent? Yep. Let's do that first. What's 3 squared? 9. 4 times 9 minus 8. Now I move on. Multiplication. Do I have multiplication? Yes. 4 times 9 is 36. Minus 8 is 28. Now you may say, Miss Reber, I don't know if you know this or not, but I can plug that problem into my calculator and I get the answer 28. Yes, I am very aware of that. But I want to know that you know how to do order of operations. So I need to see every single step. Okay? I want to see all your work. Do I think it's a good idea to plug it in the calculator and check your answer? Absolutely. There's no reason anybody should get any one of these wrong. Because like I said, I can plug in 4 times 3 squared minus 8, and my calculator tells me the answer is 28. These calculators here are smart enough to do order of operations. They're built that way, okay? So you should be able to check your work. So there's no reason you should get it wrong, all right? Next problem. Same thing, we want to plug in 3 for x. So I do 27 divided by 3 squared plus 3. All right, what would I do first, Matthew?
You would take care of that exponent there, and it would end up being 27 divided by 9 plus 3.
Very good. Exponent first, which 3 squared is 9. Okay, what would I do now, Lacey? Which I'm going to get what?
3.
27 divided by 9 is 3. And 3 plus 3 is 6. My final answer. Again, You could plug it into your calculator and check your work. All right? Let's do the next example. I want you to do these on your own, and remember, left to right rule. Left to right rule. Okay, let's see here. Sam, tell me, what did you do first in this first problem? Whoops.
Subtracted.
You subtracted. Perfect. And what did you get?
16.
Perfect. And then your final answer was 18. Very good. Okay. Riley, what did you do on this second problem first?
40 divided by 3.
Which was?
16.
Very good. And then 16 times 2 is? 32. Okay. Who can tell me, what did you do first on this third problem? Yes, ma'am. Very good. Look right here. Division. Don't get so caught up in left to right that you go, oh, 12 plus 6 is 18. 18 divided by 3. Because division comes before addition and subtraction. So I do that first. I do 12 plus 2 minus 2. Then 12 plus 2 is 14. 14 minus 2 is 12. Okay, now there's one other problem that I want to talk to you about that's like on your homework that I did not give you an example, and I want you to write this down. Okay, I want you to write this problem down. 2 times 3 squared minus 7. What I have in this problem is I have brackets, which are these square-looking parentheses, and I have parentheses. Technically, brackets and parentheses do the same thing. They mean the same thing. The only reason they're written different is so I don't have 4 sets of parentheses, because you would get confused like, well, which two go together? Okay, so the brackets kind of give me a definition. And when you have more than one set of parentheses, what you do is you always go to the innermost and do that first. So I always look to the very inside, which is right here, and this is what I want to do first. Then I work out from there. Okay, so I would do 2 times 3 first, which I would get 6, and then squared minus 7. Then, okay, what am I going to do next? Exponents. Perfect. Exactly. So I'm going to have 2 times 36 minus 7. 2 times 36, who's got that? 72. Now that I've figured that out, I can drop my brackets. And 72 minus 7 is what? 65. Very good. Okay? Okay, last example. What we've got now is, again, they just want us to do order of operations, but I've got a problem with a division bar in this, okay? And that division bar is going to do exactly that. It divides the top from the bottom. This division bar, I am not going to say, oh, because it is division, it goes in the division spot on order of operations. No. What it does is it serves as a barrier from my numerator and my denominator until the very, very end. The last step, I'm going to actually use the division bar and divide, okay? So what I'm going to do first is I like to take care of what's in the numerator. So 24 times 3 is 72. I keep my division bar, and I'm going to rewrite what's on my denominator. And then I'm going to solve on my denominator, but I need to do order of operations. This 72 hangs out up here until I need them again, okay? What would I do first in my denominator? Exponents. So I've got 5 plus 9 minus 2. And now I just use my left to right rule. 72 again hangs out up at the top. 5 plus 9 is 14 minus 2 is 12. Now you don't have to write 14 and then 14 minus 2 is 12. I understand that you can do that in your head. That's not too hard. Okay, you don't have to show me that work. All right, and then lastly, now this is where I use the division bar. What is 72 divided by 12? 6, and that is my answer. Okay, there's one other type of problem that I want to show you that is on your homework that you did not have an example of, and it would be a problem like this. Okay, write this one down. It looks like it could be maybe like one of the ones we just did with the fraction bar, but it is not. Okay, it is not. What it is 3 different fractions, and I'm going to follow order of operations. Now, at the beginning of the year is always like, oh man, fractions, I forgot about those. So I need to brush up on my fractions. So first I need to do multiplication. Do I need to have a common denominator to do multiplication with fractions? No. I just multiply straight across. So I do 5 times 2. I'm going to leave my 1/2 here. 5 times 2, which is 10. And 10 times 5, which is 50. Now I need to add these fractions. And what do these fractions have to have in order to be added together? A common denominator. So I look at my denominators. I've got 2 and I've got 50. What's a good common denominator? 50. Exactly. This one's already set. I don't need to do anything to it. What do I need to multiply by 2 in order to make it 50? 25. Whatever I multiply by the bottom, I have to do to the top. So 25 times 1 is 25 over 50 plus 10 over 50. Now, whenever you get a common denominator, do I add those denominators together and get a new denominator of 100? No. Once you've done all that work, it stays there. Your work does not go away. 50 is your denominator no matter what. And all I've got to do is add my numerators. 25 plus 10 is 35. Because this fraction can be simplified, I need to do that. What number can go into both 35 and 50? 5. So I divide each by 5. And I get 7 over what? 10. And that would be my final answer. Okay?